Hi everyone. How's it going?
Hey, hello everyone. How are you doing? I'm good. I'm good. How
Thank
are
you.
you?
I think we should get started. Good morning, everyone, or good evening, everyone. Do we have a meeting right now? Yes. Wait. So for some reason, my Slack is not working. It's Salman.
Yeah, well, I will just copy paste the meeting link here.
Yes, that will be helpful. I already sent out, of course, this link yesterday, but I guess my computer needs to be restarted. Thank you.
Yeah.
I think we should get started now.
Yep.
Before Salman starts, just one announcement, very quick announcement. Under announcement channel, I created a separate part 2 of our project management folder. So feel free to take a look. From now onwards, most of our stuff will be posted over there, part 2 specific stuff. So yeah, just FYI. Including the video links. Okay, go ahead, Salman.
Okay. So, Imran, can you give me access to screen share?
Yes, I did.
Sorry, Imran, I don't see the project management thing in the announcements. When
So
was
bookmarked. Actually, my Slack is all of a sudden stopped.
If you look at the bookmark, so I can show you.
Yes, please, that will be helpful.
For example, this is the announcement channel. If you go here at the top, you can see these are the bookmarks. So this one is part 2. So this part 2 has the videos for this second part. And if you want to go to part 1, you can go to this part 1.
Do you mind opening part 2, Salman, very quick?
Yes, I opened it. I think I shared just my.
No, directly from that announcement.
Yes, I did that. When it opens, it gives.
I see.
This is what.
So let me. If you go on table view, can you click on table view?
Oh, I don't see that part 1 and part 2 in my Slack for some reason.
In the announcements.
Yeah.
Okay. If you click, are you looking on a computer or on mobile phone?
Computer. Let me refresh my Slack for 1 second.
Maybe yes.
So under this files, under tools and tutorial, there are YouTube link as well as GitHub link is also posted as well. So everything, whatever you need to know should be over there.
Yeah, refresh worked.
Okay, that's good. Okay, now we should get started, Salman. Let's go ahead.
Okay. Okay. So technically, what we did last time on Sunday means I explained that I created the baseline model. The baseline model was when we did not do any feature selection or any sort of dimensionality reduction, but that was it. But what we ended up doing is we ended up creating the rest of the remaining, which Rich explained the KNN imputer one yesterday. He kind of like showed you that what we did is the initial pre-processing steps are pretty much same. For imputation, we are doing KNN imputation and simple imputation, 2 different imputations. So which will end up giving you different test result, means data sets. So Rich did the KNN one and I did the simple one. So the only difference between Rich's notebook and my notebook is the first thing. Let me show you. For example, if you see over here, the pipeline that I'm using, I'm putting the numerical features through simple imputer and then through standard scaler. And on the categorical, we are doing the one-hot encoding. Whereas what Rich is doing, let me open this. Okay, so what Rich is doing is the only difference over here. It's here. So for some reason, it's not displaying. It's going to throw an error. Okay, but the only thing that is happening over here is this KNN imputer. So this KNN imputer in this whole code, I changed it to simple imputer. Other than that, everything is similar on the top. And after that, what we did is we basically tried different techniques for feature selection. The third technique we tried, it is not feature selection, it is technically dimensionality reduction, or you can also call it feature engineering. Because yesterday I heard Suranjini had her, she was talking about that PCA is a black box. And sorry. So yes, it is a black box PCA, but PCA is the most efficient dimensionality reduction algorithm out there. So yes, it is a black box. What it does in the background, it's difficult to interpret. But in order to understand, anybody who is getting into machine learning or something, when you will be dealing with big amount of data sets, PCA is usually the go-to technique. Yes, there are some other techniques like t-SNE or something other than that, LDA or something, but PCA is usually it retains a lot of variance of the data. Yes, what is happening under the black box, or how to interpret those principal components that it is ended up giving you, it's difficult to interpret. Yes, but if you have large amount of data set, and reducing the dimension does it is definitely a important step. So that is why we are just doing it. We are just showing it to the beginners. We are showing several different strategies. PCA is one of it. Recursive feature elimination is one of it. In part number 1, I kind of like showed from the breakdown how RFE works. If anybody wants to understand how RFE works, I would recommend you to go to the feature engineering section videos for part 1 on YouTube channel, on Dana's YouTube channel. Go there and watch the video in which I'm discussing the RFE, where I kind of like did not use very big data set. I used a very simple data set to explain you how exactly RFE works. So if you want to understand it, I would recommend you please watch that video because I explained it kind of like in very detail. So it would not be efficient to for me to talk about it all over again. I would recommend you, since the video is already recorded, please go and watch that. So the only step that are different in all these different one, for example, simple imputer, that means my imputation is simple. And then I'm applying PCA as a dimensionality reduction. The second one, the next one is I'm applying imputation, the simple one, and then I'm applying recursive feature elimination. What recursive feature elimination, in short, what it does is it eliminates one feature. So let's say we have 60 features. What it will do is it will train the model and it will drop one feature, which one has the least importance. Now, dropping the least important, how does it assign the feature importance? Under the hood, what it does is it uses different models. For example, I can show you the RFE one. So over here, I'm using RFE and I'm using decision tree regressor. So I'm getting the feature importance from one of the tree method, decision tree. If you want to use decision tree, you can use decision tree. If you want to use any ensemble tree method, you can use, because all the tree methods by default, they assign feature importance to any feature that we are throwing into it. So they automatically assign the feature. So what RFE does is it basically runs the model and it calculates the feature importance, and the one which has the least importance, it drops it. Then it runs all the model all over again with the remaining features. Then it does exactly the same stuff. It keep on dropping one feature at a time, which has the least importance. Now, when to stop? What is the optimal number of features that you need to keep? For that, you can use RFE cross-validation, RFE CV. So that is what I did over here. I used RFE CV. Where is it? It is here. So you can see instead of RFE, I used RFE CV. It tells me that the optimal number of features in our model, it should be 43. So what I did is basically I figured out that if I keep 43 features, which this RFE is giving me, then my model would be the most efficient one. So we can pick that. Now, RFE has several different variants. Variance means technically it does not have variance. What you can do is you can change these models. When you change these models, what happens is You can use random forest here. You can use gradient boosting here. You can use EDA boosting. Any of the boosting algorithms or bagging algorithms or tree algorithms technically, which assign feature like GBM or something, you can use it. Or if you want, you can use a linear regression or lasso regression or ridge regression as well. So because what linear regression does is linear regression also assigns coefficients to every feature. So since all of our features have been scaled standard, they have been scaled using standardization. That means all of them have a mean of 0 and standard deviation of 1, which means they are all comparable to each other. That means whatever coefficient the linear regression model is assigning to every single feature is determining how important that feature is. The biggest coefficient has the biggest importance. The least coefficient has the least importance. So we can try linear regression as a estimator in here. So there are so many different possibilities we can do. But for now, for simple reasons, I just do this decision tree regressor for this part. Why? Because it is a bit faster. It is a bit more efficient than simple linear regression. That's why I did it. But if you want to use random forest, it will take a lot of time. That would be the thing we would be exploring when we are doing model development, because I don't know whether this one is giving me the best optimal answer. So I would be playing with that when I'm getting into the model development phase. So this is RFE. Then VIF is another technique. VIF is simply variance inflation factor. And variance inflation factor, what it does is basically it calculates how much variance a particular feature is kind of like representing of the overall data and something like that. And based on that, we can select a top features. So that is what we did over here. We kind of like, you can see this is so feature number 0 has infinity, means has 9 or these values. Based on that, we selected some of the features which have the highest. So we kind of like sorted them, and based on this assortment, we kind of like picked the top 4 or top 5, whatever. We don't know which one would give us the optimal answer. We have to do hit and trial run, or maybe we can do the grid search thing in order to determine, or maybe we can run it through the RFE estimator or something. So I don't know RFE works or something, but we can make our own for loop in order to test it out. So that is what we did. Then the next one is light GBM. That means I'm doing all the rest of the steps same. Only the feature selection part is based on light gradient boosting machine. It does exactly the same thing. It is a tree method. It is a boosting method, and it assigns feature importance by default. And that is what I did over here. So for example, over here, you can see this is light GBM, and it is giving importance to 118. Now you would be asking, what are these 118, 2, 3, 4 or something? So what we did is we basically split it, and since we were doing a lot of pipelines, we can just add the column in order to give them the names and everything, and it would start giving us the name which particular feature it is. But for now, it is just giving you column number 1, column number 18, column number 2, column number 3 or something. But we can assign them names very easily, which I will be doing that in coming days. So for now, it is just assigning something like that. That means we still know these are the features, and if we throw these features, now we can pick a particular threshold, and we can say that if any of the feature has importance above this, then we should keep it. Otherwise, let's drop all of them up, and we can play with that. And we don't know how many features we would be optimal. We have to tune it, and we have to optimize it. And that is what we would be doing in next 2 months, not months, 2 weeks. And then comes in the random forest. You can use random forest as a feature selector. And the similar thing with the KNN means what we did is we basically kept all these 5 things and then changed the imputer. Instead of simple, we just used KNN imputer. So what KNN imputer is and something like that, I would be explaining. So the strategy is we were talking all the leads in the group. We were talking in what we were thinking that we would be in next phase. So okay, let me wrap it up for this particular phase. Then we will talk about the next phase later. So for now, these are data pipelines. If anybody wants to play with any of the data pipeline, the data is inside them. You can go to the data. So every single folder, every single pipeline has a data folder inside it. You go to the data folder, and anything that is what you say transformed version is the final output version with all the data pipeline processes step have been implemented on it. Which means if you want to just call this X test, X train, X valid, and Y test, Y train, and Y valid, these would be your variables that you can throw into the model, and model would be you can start working on the models and everything if you want to use just this pipeline. So for now, just play with these pipelines. Last time I already showed you a baseline starter file for the model. So this was the baseline model. So if you want to throw it in this particular model, just call those variables, those files from the data, and then throw in this model. Just press run. This is plug and play. You just go to just copy this and call. So for example, if I want to play with this, I would just copy it. I would go to maybe pipeline number 2, and I will just paste it here. And now I would open it. And now I would call everything because the folder names have been given in a particular order that if I call this, it's gonna bring in all the files from here. So this particular data folder. So it is getting all the transform data. So that means you just don't even have to change anything. Just copy and paste the baseline model thing, and it's gonna start running. It means you would just start running here. So let's give it some time. And so now you see it started running. Now it is giving you the errors. So now it is running. The baseline models are pretty, but since I have more models here, right now it is working on someone which is taking more time. I think k-nearest neighbor. Then decision tree, random forest, it will take more time. And yes, so k-nearest neighbor and random forest will take more time. Other than that, they would be pretty fast. It will start giving up the results. And then if you want to do the hyperparameter tuning, these are the hyperparameter tuning for light gradient, light GBM. But if you want to change it for gradient boosting, whatever the best model you are getting, you just go and change the hyperparameters based on that. How to do that? It's pretty basic. You go to the sklearn. For example, if it is sklearn. For example, if I want to go and find the hyperparameters of a particular, for example, let's I want to do gradient boost in Recursive. I will go to Google and I will search sklearn gradient boosting regressive. So I will just search for it. You go here and you can look for, these are the parameters. So which means you can do that, or what you can do is you can always and always or you can do is you can always and always go here and you can write get underscore param. For example, whichever model you want to use, you write the name of that model and dot get underscore param. For example, if you go at the bottom, these are the
underscore para.
Get underscore param. Yeah. So over here, you can see that
dot underscore para.
Training score, init, estimator, number of estimator. So for some reason, my computer is hanging up. Okay, so you see this get underscore. So these are the methods that you can find. This get underscore parameters will give you what parameters it has. So means and then you can go and tune any of the parameters that you see fit. So it's all hit and trial. if you start doing it one at a time, you would start learning which parameters are usually used. For light GBM, technically over here, I'm just tuning 3 parameters: the learning rate, the number of estimators, and subsample. So I know why I'm doing just these 3, because there are so many parameters in light GBM, about more than 10. I'm not training all of them up. First of all, I have limited processing power, and I don't want to kind of like just train it this model, and I don't even know whether it would give me a good result or not. For I just leave it one day for it to run. No, so we can just do pick and choose. If you get a value that, for example, I'm giving 3 values: 0.01, 0.1, 0.3. First, I will run this. If my model is getting good result at 0.3, that means since I did not give values above 0.3, now I know that my value is close to 0.3 or above 0.3 maybe. So what I'm going to do is I will just next time update these and I will start maybe 0.2, 0.3, and 0.5 or 0.4. And then I will run it again. And then similarly, I mean, that is what the tuning part is. Means you go and pick and choose the values. If you get close to a particular value, then throw in closer values to that. Then throw in more closer values. This is what fine tuning means. Means that's where you can do fine tuning. So here you can see that we have run the baseline models. Now you can tune the parameters. It will take a lot of time. I'm not going to run it right now, but this is plug and play. You just copy this file, paste it into a particular pipeline, run it, and it's going to give you what kind of errors you are getting. You can see that here. Let's pick the best one. This one is giving you mean absolute error of 0.42, 0.57, 0.42. Let's look at the smallest one: 0.43, 0.45. 0.35. This one is really good. Random forest is giving out really good results as compared to the other ones. 0.38 gradient boosting is also giving light GBM as expected, and XGB. So these are all expected to give better results. They are giving better results, but these are not good results. We can fine tune them, because if you go to, for example, since this data is from the Kaggle competition, there are people who have kind of like
చెమటలు కారిపోతున్నాయేమో చెమటలు కారిపోతున్నాయి ఎంత ఒళ్ళంతా.
Sunita, can you mute yourself, please?
ఇవాళ ఫ్రైడేవా థర్స్డేవా?
Thursday.
Sunita,
రేపు జాగ్రత్తగా వెళ్ళాలి నువ్వు.
ఎస్.
can you mute yourself, please?
Okay. So means they were getting about 0.18. That is pretty half than that, which means we need a lot of work to do. And we have tried simple basic techniques right now, the plug and play. But now we can get together stacking. There are so many different techniques out there. We haven't tried neural networks here. So we can try maybe neural networks. That's what me and Imran, we were thinking that we would throw in neural networks as well, maybe deep neural networks, or simple neural networks or something. So that is what we are going to do next. So for today, let's wrap it up. This is what we have. Anybody who wants to do playing around, please play around and look at these two notebooks. They kind of like go side by side. So the reference one, just copy this baseline model and paste it in any of the pipeline and just plug and play. That's it.
Salman, I have a question over here.
Please, Vanda.
So you just explained baseline model, and in further models, like we are also doing working on simple imputer and KNN imputer. So taking your data and transform data, and do we also need to impute the data with simple or KNN imputers further after taking the data?
No. The data that we are saving, it is already being transformed, which means you don't even have to change. Everything has been done. If you are calling this x_train_transformed, it has been imputed, it has been encoded, it has been feature selection has been performed on it. All the EDA parts have been performed on it. It is a pure filtered data or clean data. So you just throw it into the model. If that is not giving you a good results, then we are going to go back and we are going to go change maybe the imputation or encoding, or maybe EDA stuff or something. Maybe when we join merge the categories, maybe we can try different strategies. Maybe we can just throw in or maybe we have to create some different features or something like that. So these are the things we are going to do right now. You don't even have to, when you are calling the baseline. So the name is baseline, but for example, this one, if you copy and paste it into the simple imputer, this one, let's say, you can just change the name for it. Yes, it is baseline, but it is not baseline. Technically, it is a template, which is calling all the data based on the folder that I have designed. Means and the names that I have been giving them in a proper way, which means if you use that way, you're gonna end up running this template through every pipeline. And now once you run it, you can compare which pipeline is giving you better results. Then you can go and deep dive into that pipeline and go and further do maybe stacking, maybe voting, or some other strategies of models and everything. Sounds good? Makes sense?
I'm not still getting it. Like we have single data, right? Transform data in one single file. So how do we come to know like whether it's imputed with simple imputer or KNN imputer?
Because you have to go to a specific folder, right? This folder is telling you that the imputation is simple and the feature selection is PCA. The name of the folder is telling you what has been done.
That I got it, but the data we are taking from that from the data folder, right? So we are taking those data sets and working on this PC and RFE, and the data set is single. So how we can say like we are working on simple imputer and KNN imputer? That part I'm not getting it.
Okay, let's look at it again. First of all, if you go to task number 4 is the data pipelines. If you go into anyone, so right now, the first one is baseline, where I'm using simple imputation and no feature selection whatsoever. That means this is the baseline. We need to beat that. Okay. So if you go in here, this is the structure. This extra is basically, I was doing some hit and trial thing. That's why this is extra right now. You can just ignore it.
Right.
This is the data, which means every single folder or every single pipeline has a data folder inside.
Okay. Right. Now I got it. Yes.
So which means if you are looking at x_test_transform.csv in this second folder, which is saying number 2, simple imputer and PCA, that data is telling you that it has a simple imputation and PCA has been done on it.
Right. Got it now. Thank you.
Okay. No problem.
Hey, Salman, I was doing something on this data. Maybe I can share it to everybody what I've been doing.
Definitely. Yeah.
Okay. Share screen. Okay, so this was the notebook that I was going by, like the baseline model. And I saw all these transformations and all these things, right? So I went into the like the cloud tools where I'm more comfortable with, like Azure. Are you able to see the screen?
Yes.
Okay, and inside there I opened up a few pipelines. For example, okay, so first I imported the data. This is the raw data that is there, right? And using this data, you can do explore, and it will give you all the columns and everything that are there, right? This one is the process data, which means that you have some cleaning and some activities there. I will show you what activities are there. So here you can see 3 pipelines. One is a pipeline created to actually calculate some values. For example, this is the main data. I go to Python script. And then here I'm doing a lot of things. I'm changing the state factor, I'm dropping the state 10, I'm creating string type variables, I'm creating the age variable, and then I'm also creating the facility type variables. And then again, I took in the bit of the code from the quarter creation from Rich, right? and then I dropped all these things and returned it. So this is the some basic processing that I'm doing on this data. After that, I'm splitting the data and I'm saving it, one for say test. So one is train, another part is test, right? So if you can see this blob store, I can see that there are two CSV files, xtrain and xtest. Right? So this one will keep separately, and then I'm creating a new pipeline using this xtrain. So this pipeline is just to execute this bit of the script, right? Create some new variables and drop some columns and stuff. The new pipeline, which is the training pipeline, this one is a bigger one. So this one, as you can see, it has the process data, which is the training data that I created here. So this training data is the process data. And after that, I am doing clipping value, so some outlier detection on the numeric features, right? By percentile and by clip peaks. And then I'm cleaning the missing data using replace with mode. So it will be the most frequent data, right? I'm not using any missing indicator value columns. And if there are any columns with all missing values, I'm just removing that column. So these are all the numeric columns. After that, I'm editing the metadata where these four variables are actually categorical types. So I'm just converting them to categorical, right? And after that, I'm converting to indicator values, which means it will become like 010101, right? And I'm overwriting the categorical column. So original columns will go away, only the indicator columns will be there.
Sounds good.
Okay, after that, I'm doing the scaling part, the normalization on all the numeric columns. And I'm using the Z-score method to do the scaling, like the standard scaler.
Yeah.
And finally, I'm doing a math operation, which will basically take a logarithmic of the site EUI and just change the variable in place instead of appending it as a new column. Right? So after this entire pipeline, I go and split the data again. And this time I keep one data set for training and the other data set for validation.
Sounds good.
So one data set, the first one, I am using a train model object where the model will be a boosted decision tree, like a XGB boosted tree. Here you can give different parameters, single parameter, number of leaves, all the options that you can give in scikit-learn you can give here. And once you have the trained model, for now the model explanations are false.
Okay. Ms. Roy.
He's not here.
Well, his stuff was good. I'm glad that he stepped up, but I guess that's perfect as one of the, he should become a task lead, and maybe it should give demonstration, because there are many beginner levels participants as well. They may not be able to keep up. And that's the whole idea for why we created that.
Yep, that's right.
But that was good, that Azure thing. It's good that people get the exposure to.
Means I find that Azure, it's kind of like make your life pretty easy. It's just a drop down menu and that's it. You don't even have to write the code. That's amazing.
No, these cloud servers, that's the best part of these, like AWS, and I've used that Azure as well. That makes life so much easier. Just
yes.
Yeah, but somewhere I feel the little fun of coding is lost. I like the.
Yes.
I
totally agree with you, Sunil.
I like to write the code on the Jupyter Notebook or PyCharm, whatever it is. More fun.
The only problem with Azure, is it's all drag and drop, and you will not understand what's happening in behind the scenes.
Absolutely.
So you need to know all nitty-gritty work right now, which we are doing, to have a whole understanding. After that, once you're proficient, then maybe.
Right.
But still, we can still use Azure in order for deployment. We're using our own code, our own Jupyter Notebook. It gives us the opportunity to do that as well.
Yeah.
Maybe in the end of this part, we can have like a few lectures on Azure or AWS.
I got cut out in between. Did you see any of the final pieces of the presentation?
No. You would have to do the last part again. I was really enjoying it. You can share it.
You can share it, but here's the thing. For our upcoming few lectures, this is why there's a sign-up sheet. Did anybody see that?
Yeah, people have registered also, but as a teammate and
Exactly. So we need maybe this
not
ROI stuff is pretty good, and we need to maybe we can spend a little bit more time understanding his logic. I think he's rushing a bit, and I'm sure many participants would be interested. It's a good thing to know for to get enough exposure. So maybe he can sign up for that if he's comfortable.
Because we have very little time, that's why I tried to rush it up a little.
No, that's perfectly fine. Thanks a lot for stepping up. That's good that we didn't know otherwise that that's pretty quality stuff. Maybe for that particular time slot, you can, if you can sign up in that sheet. Did you see that sheet, Roy?
Which sheet are you talking about?
Komal, can you share him the link?
The announcement folder.
Because this is a good stuff. We don't want to just rush it through. I would rather have separate time for that.
Oh, it says task lead, task co-lead, teammate, command.
Yes. So if you can sign up as a task lead or co-lead, so I think in your case, maybe task lead for that one, it will be helpful demonstration as far as Azure is concerned. What do you guys all think?
Definitely, yeah.
Right, because right now it's kind of rushed session. That's not that good.
Yeah, I can.
Could you open the sheet?
Details. I can take you in details through all those things.
That would be great, right? So if you can sign up your name, I think we can allocate a particular day for that.
Sure.
Thanks a lot, Roy, for sharing. For now, I didn't mean to interrupt, but I really want that to go in more detail. We are kind of running out of time at this point. Right now, if Salman, if you can finish your agenda, and then we can. It's a work day, so that's the only concern. Otherwise, it shouldn't be a problem.
Yeah. Okay. So what I was thinking is since so far I think we have 3 teams now for the next 2 weeks. I think I know Benita was saying that she is working on the times free stuff, so she would be presenting something on Sunday. So that would be one of the aspect that definitely we have to take or explore it that way as well. And if anybody else is kind of like willing to step up and take a responsibility for taking a task lead, and they want to explore on their own what kind of model or what kind of a technique, what kind of an ensemble out of the different techniques they want to do, and do some model development and evaluation part, please feel free to do that, because the goal is kind of like in this role, when I joined this role, I know that I learn better when I'm explaining things, when I'm kind of like going through and people are asking me questions that makes me think in a different way that I cannot think myself. Those questions I cannot think myself. So some other people are asking me those questions that make me think in a different way. And it also gives you a confidence in kind of like when you go to the interviews and everything, you would be explaining stuff because there would be coding interviews, there would be technical interviews. That means this is a chance where you can step up and you can practice that thing that when you are in front of an employer and they are asking you technical questions, you can ask them confident or reply to them confidently and everything. This is something which I'm learning and every single day means explaining makes you kind of like a better thinker and a better troubleshooter, I believe. So I would recommend you please sign up for the task lead role. You want to explore certain things, do that. Means this is where, and when you are taking task lead, that does not mean you are on your own. We would be helping each other out. So don't consider that that you would be doing everything on your own. If you get stuck somewhere, we are all here to help. So please feel free to step up and take some responsibility, and that kind of like gives you a connection with the project as well. And we want to kind of like make this project as a kind of like portfolio worthy project for everyone. So everybody can put it on their GitHub and put it in the resume that they did this work. And we did a lot of techniques and a lot of these things. And I was in charge of this particular section, and we got these results and everything. So in your resume, you can talk about exactly what results you achieved, your team achieved, how many members you kind of like supervised or things like that. So please do that. I would recommend it. Thank you.
Thanks, Salman, for sharing your perspective on that. Definitely highly recommended. Also remember with that task lead, you have a co-lead as well, co-task lead as well. So you will be working. There should be a manpower as well. So don't think there's just all everything and fall on you. And we are working as one team. So as Salman said, just messages and we will help out as much as we can. But the idea is for all of us to grow together and get a good holistic end-to-end skill set of this ML pipeline. So yes. Anything else, Salman?
Yes. So this Sunday, what I'm planning to do I know that there are a lot of beginners. So for those beginners specifically, what I would be doing, the baseline model thing that I was showing you, there are 15 models in it. I will kind of like go and explain every single model, how it works. Okay. So not possibly all 15 of them, because the tree one, they all work similarly. So I would just explain one of it, and all of them are kind of like the same way. There are a few tweaks here and there, and they become a different model. So it's kind of like, I will kind of like give an overview of how those models works, and I will show you one model at a time, how this model can be implemented. Then the next one, then the next one. Right now in the notebook, we are implementing all of them all together. It is a very big chunk of code, and you don't know what is happening inside and everything. So I will be breaking it down into model by model. So what one model is giving us, how we can tweak it, then the next model, how we can tweak it, then the next model, how we can tweak it, or something like that. Yes, it will not take a lot of time. I will spend some basic time on some basic models like linear regression, lasso, and ridge. They are pretty similar. There are only regularization that is being added. Other than that, they work pretty similar. Similarly, tree models, they work pretty similar. KNN is different, so I will explain KNN separately. Similarly, gradient boosting and everything, they work similar. So I will kind of like summarize them. So next Sunday, anybody who is beginner, don't get overwhelmed by a lot of models that we are throwing in here. We will try to kind of like cover up the basics for the beginners as well, so that they can break it down, and they can do one model at a time. You don't have to combine all the models all together. One model at a time should be fine, because I know that when I was a beginner, if I'm looking at a code like this, I'm all lost. So we would be kind of like breaking it down.
Thanks a lot, Salman. I think that will be a great help. And yes, definitely. I'm really excited. I'm sure many would appreciate this. Okay, now we need to wrap up soon. I see many people haven't put up their names on the list, the link which Komal shared. Please put up your name, and we will.
Hey, Imran, I
Yes.
have a question.
Yes.
So this is Mansa. So, so when you see the team, right? Like, how are we going to split up the task within the team? Like, I still didn't get understanding of that.
Okay. On that one, we are first of all thinking that maybe who are the, well, once the teams are there, we are thinking maybe to have a team meeting with the team leads and then decide a strategy. But one we were thinking maybe team lead and task lead and co-task lead, they can decide how they can meet up their sub team, and they can plan out things to just keep all their 5-6 people under them. They work together in terms of how they want to strategize as one small team, and then they present to holistically to our team. So maybe they will have their own separate team, separate meetings to coordinate their work and approach it their own way, taking a leadership within their own bubble. You see what I mean?
Okay.
So Imran, apart from these meetings, we'll be having some more meetings with these new teams,
So
right?
that's just one of the way, right? Otherwise, you can suggest if we can, how else can we suggest it or shrink it down? What do you think, Salman?
Yes, I think it depends on team to team. Once you pick a particular team, then we will sit together, maybe in one meeting or something, very quick meeting for that particular group team, and then we will assign or think about what should be our strategy, what avenues we want to explore, and who is comfortable with what, and based on that we can assign that you can do this, you can do that, you can do that, and then we can merge all it together, and we would have, because for example, if I'm doing the lead thing means I'm doing one of the lead. That means what I would be doing is I would be sitting with the co-lead. Imran is my co-lead. So we would be sitting together and we would be forming a strategy that it's not like everybody is working on one thing. So we should work on separate different things and see which one is working well, and then explore that in detail. So that is something which we will kind of like we would have to do team by team. Every team would have different strategies and different structure, how they wanted to go about, when they would be meeting and everything. It would not be meeting for everyone for that specific team. So I think it would be just team specific.
Thanks, Salman, for elaborating. That's pretty much almost what I meant. Yes. Does it make sense, everyone?
Yes.
Okay, good. So I think it would be better if all of you just put up your names on the sign-up sheet, so at least we get an idea how the whole structure looks like, and then we will have a separate meeting, very short, small meeting among all the leads, and then we'll decide how we're gonna roll it out among all the participants. Okay. Any other questions?
Yeah, just one additional thing, because if we don't have more people coming up volunteering as leads, and we still have more team members, you are not finding place in the Excel sheet, please feel free to get yourself added in one of the 3 teams which are already made. So just add the columns at the end. Did I
Yes.
make sense?
Yes. Yes.
Yeah.
Yes.
So it's not that the existing teams are already filled. It's not the 4 is not the maximum number of teammates that we are talking about. It's just a placeholder. If you don't find any place in existing teams, just add yourself in Salman, Rich's, or Roy's teams.
Yeah. Okay, Komal. Thank you.
Okay. Any other questions, anyone?
Can we also be team member in a different team and also lead in another team?
You can. For that, I would say wait a day. Let's see if those slots are filled up. I ideally prefer everybody get a chance to become a lead or co-lead. If they are not, then I guess if there's spots still available, then yes, why not?
Okay.
Okay. Any other questions, anyone? Okay.
When is the
Sorry, go ahead.
next meeting?
Sorry.
When is the next meeting?
It's always Sunday and Wednesdays for the most
Sunday.
part, unless there is an exception, then we make an announcement. So next we are meeting Sunday, 9 a.m. Eastern time, US Eastern time. Okay. Well, have a good day, everyone.
Thank you very much.
See you guys on Sunday.
Thank you.
Thank you.
Take care. Bye-bye.